All right, welcome to the PPIM 2024 edition of Pipeline Things. I am your host, Rhett Dotson, my co-host, Mr. Christopher DeLeon, and we have an esteemed guest. Would you like to quickly say your name while
I'm Jimmy Campbell from Plastometrex in the UK.
So, Plastometrex, and thus you now have the segue for this episode. So, Jimmy, I'm from Louisiana, and people, South Louisiana, like you have to distinguish in Louisiana, South and North Louisiana, and we have our own funny accents due to our Cajun heritage and things we say. Mine is largely gone after spending 20 plus years in Texas.
There's sense of it.
There's bits of it. Yeah, like a lot of times I used to say, my roommates used to make fun of me because I would say like $50. And you know, when you go to, if you ever find yourself like in Lafayette or south of I-10 in Louisiana, they'll call you like, "Hey, darling," and "baby," and all these like.
Is that his nickname now? Is that what you're saying?
Dolan? You want to call him Dolan?
That really can't catch him.
I'm not sure where this is going. Is what I'm getting to.
Right. Have you ever seen the movie Waterboy? Did you ever see that?
I have not.
Okay.
High quality H2O, baby.
Yep. Jimmy Boucher is that's an Adam Sandler movie from back whenever I was a kid.
Okay.
Anyway, they blatantly and probably in a way that's no longer acceptable in today's cancel culture, the way a lot of people in South Louisiana speak. But the reason I'm bringing this up is that there was a debate prior to having you on over the proper way to pronounce the company's name, right? And so Christopher over here was Plastometrex.
It is Plastometrics.
Right.
It's not.
All right. So again, can you give us a real quick lesson on the proper pronunciation?
In Spanish, we would use tildes and accent marks to indicate how to pronounce it. And I don't see any of that in the name, so it's Plastometrics.
Well, that's because we thought it was straightforward, right?
the mother language.
but I have to, we have to be fair. We have employees who might still say Plastometrics.
Yeah.
And we have to say no, it's Plastometrex.
Yeah.
So one of our guys is called Tom. It's pretty straightforward.
Yeah.
Tom, it's got your name in it. So Plastometrex. You'll never forget.
Tom has his name in it.
Tom has his name in it, exactly.
So Tom is a boss.
Yeah, exactly.
So while we're on the subject of the mother language and some of the other things, can you comment on aluminium?
Aluminum.
Look,
aluminum.
There's some seriously good news on that front, is that very few pipelines are made out of aluminium. And therefore, when we're at PPIM, we don't need to worry too much.
Well, fantastic. So, yeah,
it's still low carbon steel in American English, right?
It is. It is. But we never ever cease to get amazed at. We just don't understand where aluminium came from. Like, there's not a. It doesn't enunciate. The actual letters aren't there in that one, but it's great fun. Thanks for entertaining our segue on Plastometrix. See, I feel like I've got it now. It does. I will say, Plastometrix rolls off the tongue.
I think
much
it
better
really
than
pops, to be honest.
Plastometrics. Yes,
I agree.
It does. But tell us a little bit. How did Plastometrix come to be? How did you guys arrive? Why might our audience be interested in hearing from you today?
For sure. Yeah. So, by way of background, so we founded late in 2018. So we've just celebrated our 5th birthday. But that was on the back of 10 plus years of research work at the University of Cambridge in the UK. So myself and a few of the other co-founders of the company were there doing research looking at indentation-based methods to determine tensile properties. So that would be yield strength and tensile strength from a simple test where you push a hard sphere into the surface of a metal. So we spent about 10 years or so developing those kind of techniques. And in 2018 felt like we had enough to go kind of commercial, if you like, with the endeavor. So after that, we then went about designing our first product. So that was initially a benchtop machine designed to be used in the lab. And from there, we're now here at PPIM because we have a portable machine which can be used out in the field to test pipelines.
So you started in 2018 with the development of the benchtop machine?
For sure, yeah.
All right. And so when did you roll out when was the benchtop machine commercial?
So it was 2020, which was not a great time.
But say, like, y'all were like,
yeah.
Hey, you know what? I got a business idea. Let's launch it right in the middle of the world's longest running, biggest pandemic in the last century.
It wasn't ideal in terms of timing, but I think that made our traction and sales, even more impressive at the time. So we launched it in 2020. We achieved global sales of the machine that year. So we're now on every continent apart from Antarctica. I'm sure we'll get there.
Is that better? Because when we prepped for the podcast, you said that the same way apart from Antarctica. Is there a big market that you are currently missing And so we're going to talk about another one. There's a C, Antarctica.
There is.
Antarctica. Is there a big market there that you guys are trying to corner?
I don't think so, but we keep an open mind on these things.
Okay.
So if there are anyone out there who's watching this from Antarctica who's looking for testing of their metals, then we'd love to hear from them.
And so clearly, I'm guessing in Antarctica you don't have any temperature-dependent issues.
No, that's true. It's all pretty cold.
So, now you're curious because you said, again, by the time you guys got ready to launch your desktop machine in 2018, you were already 10 years into the research game, which means you would have been starting this around 2008. And that was curious for me. What was the driver in 2008 for you guys for getting into this field of research? Can you share a little bit about that?
Sure. So, I mean, in the academic sphere, there's a lot of universities all over the world doing research into obviously metallics and testing, and there's a large community around something called nano indentation, so very fine scale testing. So this is not, I would say, we were not the first to try this. So a couple of the kind of key things that we realized over that period were people worldwide are doing nano indentation, super fine scale, often only in a single grain of the material. So if you're trying to determine bulk tensile properties, you haven't really got a chance. So it was during my PhD that we scaled everything up. So we went from using indenters of, say, 50 microns, which might be very sensitive to things like vibration, and you're still in, as I say, a single grain. Scaled everything up. So we now use an indenter of 1 millimeter radius. So it's pretty macro scale in many ways. And then there's a couple of things that you can look at from any indentation test. So when you do an indent, and I guess people would be most familiar with hardness tests,
Sure.
You'd create the indent and you look at the size, the diameter of what's left behind. The other thing you can do is look at live. You can look at load versus displacement. So we looked at both of those things and said, is there any way of using the data, either from a hardness test or a load displacement test, to predict the properties we're interested in? Tensile strength, yield strength. And we realized it was really very difficult. So you have to get everything very, very accurate to really get a good sense of what is a yield stress and tensile strength. And we moved to the process we use now, which is where we create the indent, and then we look at the shape of what's left behind afterwards. So we take the surface topography. So we have a spherical inner portion of our indent, and the region around the rim is called the pilot region. Now that pilot region gives you loads of information about how the deformation has taken place and what the properties are. So our process now looks like you create the indent, you then scan the shape of the profile, and the way that we then go from profile to the prediction of properties is we use finite element analysis. So we can run our model and we can, if you like, take a guess at the properties, and we can simulate what does the shape look like, and then we can adjust the properties until the shape of our model matches that of our experiment, and at that point we can accurately predict the properties.
So a couple of key things come to mind there. You're indenting, so this is closer, but not to be confused with indentation testing, which a lot of people are familiar with. This is actually a slightly different form of indentation because you're looking at the deformation around the rim, not just, as you mentioned, the load displacement curve. There.
That's a key point, I would say.
Yeah. The other thing that I thought was really funny is I'm imagining y'all, everybody in our industry is driven around trying to go smaller sensors, tinier things. And y'all actually went from nano back the other way. It's kind of like we're going to need a bigger boat. That's what I'm...
I wish I could tell you, but the next podcast I'm on, I'm going to say that's what happened in the meeting. So there's kind of a fundamental limitation, right? If your grain size, you have to make sure that your indent is large relative to the microstructure that you're testing. So your grain size has to be fine relative to the indenter size. So 1 millimeter radius covers us in the vast majority of cases to guarantee we're going to get what we call a bulk response to the material.
All right. And so now you guys have moved beyond, right? So we talked about this desktop thing, but obviously a desktop thing's not going to work in the field. You guys now have a field unit that you're rolling out as well, right?
So if I can, I actually want to change. So I want to go timeout here. So you're at Cambridge, you're doing research. How'd you end up in pipelines, right? Because I mean, that's the thing. Like, this isn't novel. Like, we all kind of have this story of like, I never thought I was going to be in pipelines, and 30 years later, here I am. How'd you end up in pipelines?
Well, first of all, I never thought I'd be in indentation. That was an interesting move, I guess, back in the day. But that's where my career is now. So I think the key step was we had the benchtop unit. We'd started selling the benchtop unit, and that's when we became aware of the mega rule.
Okay.
So we were told by actually some of the guys we know at the Element Materials Technology Lab here in Houston.
Yep.
They mentioned, there's this new rule that's coming in the oil and gas sector. You might want to take a look and see if that's applicable to you. So we had a look at the legislation. We thought, okay, definitely something that we could satisfy some of the requirements of. We just need a different machine. So at that point, we partnered with Rosen in the UK.
Okay.
So they supported a UK government grant that allowed us to get the funding to develop the new product to go directly on the pipeline. So that's kind of how it happened. And then that process, we started the project in November, just over 2 years ago.
Yeah.
So we started with like you've said, taking the lab-based device, what changes do we need to make to get that out into the field to make it reliable? And then here we are today, we've got the lab-based device, we've done a huge validation project, and now it's ready to go.
So like most of us, pipelines found you.
Absolutely, yeah. I tell you, some of these I'm going to use again in the future. There's absolutely no doubt.
So I am sure it had to be at least a somewhat entertaining journey to go from benchtop to the field, because
sure.
pipelines bear no resemblance to the lab. I love laboratory settings, especially when we talk about like repair methodologies and things in our industry, because we do these in a lab setting. And anybody who's been in a ditch, the first ditch you find, it's raining, it's muddy, the bottom of it's got 6 inches of water, and you find yourself laying on the back of a pallet staring up at the bottom of a pipe, and it's raining on top of you. How challenging was it to go from the lab where you can control the environment into the uncontrolled Wild West of the pipeline ditches?
I think it was certainly a challenge. But we had learned from experience with the benchtop that these things were never as simple as you think. So we sat in early investor meetings when we had the science behind us, if you like, and I pretty confidently said to them, we've solved the difficult problem now. We've completed the science. Now we just need to build the hardware, and that probably will be quite easy. And that turned out to not be the case for the lab-based machine. So we learned by experience there. It's a more difficult process developing hardware than you might think. So what we did was very early we scoped what the requirements would be. So we spoke with a lot of operators, service providers, and understood, okay, what are the differences? What are the issues you maybe see with technologies you use out in the field right now? How can we potentially overcome those? So, and we then looked at, what does the benchtop machine look like, and what changes do we think we'll have to make sure that it is good enough to go out in the field. So one obvious one that we knew from sort of day one was we use a stylus profilometer in the benchtop unit. That just drags along the surface of the pipe. That was not going to work, for example, underneath the pipe at 6 o'clock, because the profilometer is acts under gravity. It would not be in contact with the pipe.
So there we go. We recently had an opportunity to talk to Mr. Bruce Nesselroth, and he mentioned something to us. He said, science is about truth. Engineering is about compromise.
It's very true. Look, we now see that, almost every day in our lives, is that you have to compromise on certain things. We would love to have a machine that did everything automated and the operator didn't have to touch it, but you have to compromise at some point. So the machine we've designed is simple and easy to use, but it still requires the intervention of our operator to do it.
All right, so we're actually going to take a real quick break, Jimmy. We're going to come back, and when we come back, audience, we're going to talk about what this unit can actually do in terms of its specifications, qualifications, any limitations it might have. So hang on, and we'll be right back.
Hello, everyone. It's BJ Lowe from Clarion, and we're very happy to be sponsoring this season of Pipeline Things to showcase the impressive technologies being exhibited here at PPIM.
I'm Ben Stroman, and we've been impressed with the turnout at the 36th PPIM conference event in 2024, with 159 companies exhibiting, over 3,000 attendees, and over 90 papers being presented. We've had a great year with a huge turnout in terms of high-quality technical paper submissions. Attendees this year will have the opportunity to hear from industry stakeholders and their advancements in several fields, including ILI analysis, geohazards, materials identification and verification, emerging issues, repair, hydrogen, integrity management, NDT, and more. If you couldn't make it in person to the PPIM conference in February, you can always find helpful resources and tools offered by Clarion year-round. We have several courses taught by subject matter experts that can be found on our website. We're excited for PPIM this year, and we hope to see everyone next year as well. But be sure to stay up to date with Clarion and its offerings by joining our mailing list on our website. Thanks.
All right, welcome back as we are on our PPIM 2024 arc with our guest, Mr. Jimmy Campbell of Plastometrex.
Plastometrex.
No, see, it's so Plastometrex rolls.
Tom is going to come out.
Just remember, it's Tom. He's
Tom.
going to be really upset if you
Tom's
keep
gonna
saying it
come
like
get
that.
me.
Plastometrex. Yeah, his name's not Tom, it's Tom. So, Jimmy, we're going back, and I want to pick up right where we left off. So, I want to play the role of an operator. I'm an operator. I hire you guys. It's hire you guys. Are you also on the equipment or the service, number one?
So we are a technology provider. We
provider.
operate the same business model as our benchtop. So we sell the units to service providers or end users.
Whoever they be. So
technology.
I contact service provider X, who's going to bring your unit, Plastometrex, out to my dig site. What should I expect?
So the kit comes in 2 or 3 pelly cases, depending on the size of the pipe that needs to be tested. Once you're on site, you do need a generator, so we do need power to run the units.
What type of generator are we talking about? Are we talking like a really big one? Or are we talking like a little tiny Honda portable one?
Just a standard generator.
Did y'all convert to 120, or are we running off of 220?
So we faced this one very early on. So we have a power supply that is compatible with 110 or to 120 or 240 volts. So we're good. It's an international bit of equipment.
Okay, I was just curious because you did start with a mega rule, so I figured one of the engineering constraints was U.S. standard units and the way we like to operate.
You know darn good and well they showed up to the first ditch with a 220. Somebody's got to go to Home Depot.
What kind of plug is this? How do you plug it in?
So yeah, actually, some of the electrical systems you can get these days very flexible. So the one we have can be plugged into either voltage supply and it will work just fine.
Okay.
So you arrive at the ditch, you need a generator to run it, and then the first step is to prepare the surface of the pipe. So we need to first of all remove any coating, and then we recommend that you use effectively just a sander to take down to a 600 grit. Okay. So that process, we only need a small area, maybe 2 inches by 1 inch maximum. And that process usually takes maybe 10 to 15 minutes to do 2 quadrants.
So that makes me think it's kind of easy for you to line up your kit because if you're only surface prepping maybe this big, your tech's not in there trying to figure out how to line it up.
No, it's super straightforward. So we have, then what you do is you attach the cradle. So we call it the cradle, which effectively holds the indenter and the profilometer in place. Yeah. So that's got a big strap that goes around the outside to hold it sort of roughly in place. And then we attach bars, which effectively you just tighten up to attach it firmly so you can then apply the load needed for the indent. Now, and that part we effectively have just a small 3D printed aligner where you simply put it on the cradle and it'll tell you exactly where your 5 tests are going to go.
So I'm kind of curious now, right? So you say cradle. I assume this is your baby. Is the baby's name Tom?
You watch it from cradle to grave.
Or does this technology is the kit called Plastometrex?
The baby, if you like, it's called the PLX-Portable.
So PLX-Portable.
So
thank you.
We maybe after today we'll switch the whole name to PLX. Let's see. We'll get some feedback from the viewers about the name. So the cradle simply attaches to the pipe. Okay. It has to be held pretty rigidly because we're going to generate reasonably high loads.
Okay.
And then once the cradle is in position and tightened up, which again maybe takes about 15 minutes to set it up in position, you simply attach the indenter module. You do your 5 tests, and we have locator pins at the 5 different points. So you simply push the equipment along, you click go on the software, and then it'll carry out the next test, push it along to the next one. So you create 5 indents, you then take off the indenter module, attach the profilometer, and scan the shape of those 5 indents.
And for clarity, all 5 within the 2x1 inch.
Absolutely.
You're not prepping 5 2x1 inch surface areas.
No.
Unless you wanted to do different quadrants.
Yeah,
for sure. Yeah. So typically, people would do a minimum of 2 quadrants. So you might prep 2 of those areas before you start, and then you would simply finish the set of tests. So the 5 set of scans. We rotate the cradle, which is really straightforward, and then lock it down again, do the second set.
Start to finish, how long does it take?
So start to finish, we'll look at, so we are doing tests right now, reliability testing and seeing how we can get this time down as much as possible.
Sure.
But I think we're looking, if you do a check-in at the start, so on a known sample, and then you do your 2 quadrants, and then you do your final checkout, you're looking at about 2 hours total to do those. So it's pretty competitive with.
And what's the output? Whenever what kind of report are they going to expect, and what's the timing on that report?
So the results are available live in the ditch. So there is no waiting for a report. The results are there then on the screen. And then you can select in the software what level of report you would like. So
that is really helpful. So if you don't get results that you like, you just try again.
Yeah, so look, there are situations in pipeline testing where look, there are
It took him a minute to catch that. He's like,
I was like, did he just say that on the live?
there are situations where we have seen genuine variations in properties between the 2 o'clock and the 6 o'clock, for example. So if you do want to go back, at least there and then that you've got the ability to go. You prep another.
Well, you could just
area.
check another quadrant. Maybe you have an alternate approach. I guess one of the things I'm curious about is this is a in situ technology, and a lot of us are behaviorally trained to talk about calibration processes.
Yeah, for sure.
Right. Anything you can share about calibration that's required in the ditch?
Yeah, so there are effectively two sensors that are key to getting good results. The first one is the load cell to make sure that the load that we apply is correct. The second one is the profilometer calibration, which effectively is based on the wavelength of the light. So it's an interferometer type technology. So you don't need, as the user, to do either of those in the ditch. We'd recommend, in line with typical quality processes, you do a load cell calibration once per year, and we will do that for you. And then the interferometer, I say, it can be checked, but because it's based on the wavelength of light, it should be fine. What we'd recommend, is just to do a check on a known sample, again, which we can supply. Just before you go into the ditch, you check you get the right numbers in terms of yield, tensile strength, and then you can carry on with your testing.
So before the break, we talked about kind of how it works, right?
Yeah.
We did a lot about indentation, shape, rim, and now you said you saw the light. What does the light have to do with it?
So the light is just a way of getting the shape. That's all. So
Okay.
The profilometer uses a light-based technology to measure the shape. So we get the full.
Can I give you some advice, Jimmy? Sure. You keep saying this word profilometer, and I'm sure that that's a great word, but if you said like laser scanner, it's like
sounds so much better, doesn't
practical.
There's a reason. One of your most famous actors said sharks with freaking laser beams on their heads.
Okay, so what do we think? Maybe like red light laser surface scanner? Too long?
Yes.
Too long.
Just laser scanner. We get that.
Okay.
It doesn't even matter if it's laser.
It's not a laser.
It's futuristic. See, that's exactly.
And it doesn't have to be red. You could say something cool like blue or like ice blue.
But you should do that. And look, total marketing. While it's scanning in the ditch, it should be like flashing red and blue all around, with LEDs going off.
You can't steal that idea. We've already got the LEDs. So actually, we were at a trade show right when we started with our first ever prototype. No lights, and this guy came over and he said,
"What's it doing?"
He looked at it and
Is
went,
it on?
He went,
poking at the baby.
"Is it dead?" And we were like, slightly offensive, but okay. So we added lights, and you can see it on our website.
Non-functional lights.
No, totally functional. So blue is ready.
But
green,
does it flash while it's
yes.
running?
So green it builds up, and green means it's indenting, and then yellow means profilometry is taking place.
So hold
and
on.
the one we don't like to see is the red
Let
flashing,
it finish. Oh, red is bad. So
because you know what that means.
So if our perspective was he was doing this.
Sorry,
So does it do a smiley face when it's done? Is that what the light pattern does?
It looks
so
a
you're
little
happy?
bit like a smiley face.
I was gonna say you should even tell people you should say when it's testing there has to be a 3-foot clear radius around it because what's happening there is very, very sensitive.
It's magic. You don't want it to get on you.
But the key really
The more
is.
mysterious that you make it, Jimmy, the better it works.
Oh, so we're desperate to make it not mysterious and be very open with how the technology works, our validation data, etc. And the lights, also not designed to be mysterious. They're meant to give the user knowledge of what's happening in the test. Is the equipment connected? And has there been any kind of problem?
in the ditch, any limitations? You mentioned you guys can do 6 o'clock, no problems.
6 o'clock, no problem.
What types of clearance underneath do you need to do 6 o'clock?
So I think approximately just over a foot, probably. You need slightly more than the height of the unit to get it on, but the unit is about a foot high.
Have you done the testing at 6 o'clock yet yourself, since you're saying it's capable of doing this?
So personally, I have not. And the reason for that is we were going out.
Because you're the engineer.
We were going out in the ditch last week. But the weather was.
That's when you specify 6 o'clock.
But this was something else last week. So
was it in Texas by chance?
This was in the UK. So we've dug ditches both in the UK and here in Texas. So we're working with the PRCI, just 20 minutes or so from here.
Yeah.
So we've got ditches both in the UK and here for simulated testing, but also for training of operators to go out in the field. But we're reliably told that when the weather is too bad, that people don't go out in the ditch. And our CEO looked out into the ditch and he said, "You guys can't test out there today." So that's my excuse. But I promise the next occasion we go out in the ditch, the next time I go out,
been 6 o'clock.
I will send you a picture of me doing the 6 o'clock. But
wish.
just to confirm, we have done it and it does work.
Rite of passage.
As an engineer, I used to specify a lot of measurements at 6 o'clock until they made me get in the ditch and do them. And I was like, 6 o'clock, maybe we don't need that.
I think 4
measurement.
o'clock is going to be just fine.
Yes, exactly. Well, I tell you what, Jimmy, I've really enjoyed this. Can you tell us any as we wrap things up, any parting words on where the future of Plastometrex is headed over the next couple of years? Where do you see this going? Or y'all, I mean, obviously, development's never static, so I assume you're continuing to do new things. Anything you're willing to share?
Yeah, so I think just a couple of things before we wrap up. So the first one to share is we have our validation data is on our website now. So that is now open to the public to go out there and get that data. So we've done validation testing with a lot of different operators, and we've then done in-ditch and in-yard testing as blind trials. So I'll be presenting some of that data at the show this week as part of the paper. Yeah. And then looking forward, we're going to set up a base here in the US. So we will have boots on the ground effectively from next month. So that's pretty exciting for us as we look to support our customers as well as possible. And then as we look forward, we're going to be assessing different requirements, I guess, of customers. So whether that be testing of welds, we're going to look at different material properties that we might be able to assess with our methods. We're keeping a pretty open mind, but I think in the early days, what we're really trying to do is support our customers as much as possible, make sure that they can get that data live in the ditch every time, and then look to get our tools as wide out there as possible.
All right. Well, Jimmy, I would like to thank you and Plastometrex for joining us today on Pipeline Things.
Thank you.
I look forward to seeing how you guys roll out this technology and hearing more about it. It's definitely a needed area in our industry. So our audience, we hope you enjoyed this episode on the PPIM 2024 ARC. Continue listening. We're going to have lots more coming your way from PPIM 2024. Thanks, and see you in 2 weeks.